We are now on the last installment of the time value of money topic. The previous two videos talked about simple interest, compound interest, and of course the future value. You need to see those two videos first before you continue with this video to fully understand this video lecture. The link is on the description below. In this video, we will be talking about present value as applied in interest and non-interest bearing notes or debts. They say, if you want to really learn something, you should start by asking the right questions before your quest to finding the right answers. So in this video lecture today, we are going to answer 4 questions only. But before we go to that, I have presented you with a problem in the last episode and I promised that I will give you the answer in the next video. So this is the problem. You want to have 1 million at the end of the year, so you decided to invest 230,000 per quarter. What should be the annual interest rate or annual growth rate? And the answer is 22.36% per annum or 5.59% per quarter. So I have proof here, but I'm going to trust you with the solution. So you're in charge with the solution. Anyways, here is the timeline analysis. Based on the problem, you are to invest 230,000 here, and here, and here, and lastly, here at the end of quarter 4. Now, if you sum this up, it is only 920,000 and we need to have 1 million at the end of the year. So what should be the growth rate? Again, our answer is 5.59%. So let's apply that to the timeline and we will multiply the investments with 1.0559 or 105.59%. So you have 230,000 times 1.0559, you will have 242,857 plus 230,000, then you're gonna get 472,857 at the end of quarter 2, and then you multiply that amount with 1.0559 again, you're gonna get 499,290 plus 230,000, then you'll have 729,290, and lastly multiply that with the final 1.0559, then you're going to get 770,057 plus the final 230,000, then you are going to get a total of 1,057,000 pesos. So the 57 pesos is due to rounding of factors. So if you want an exact answer, do an interpolation again as discussed in the previous video using the 2 trial rates, which will result nearest to our desired future value of 1 million. So that's the end of the flashback. One more thing before we answer the 4 questions I mentioned earlier. We need to answer, what is the present value analysis, or what is this present value concepts all about? So, while future value concepts are applied to transactions like investments based on our previous videos, especially when you want to answer questions like, how much will be my investment in the future? Or, if I want to have this much in the future, how much will I invest now? Or, if I have this money now and I want it to grow to a specific amount in the future, what should be the growth rate to make it happen? So, present value analysis is used when we are talking about receivables or payables, mainly answering the question, if I or someone have to pay this amount in the future, how much is really the payable or receivable that needs to be recognized now? If you understood that, then it's time to answer the first out of the 4 questions that I've mentioned before. The question number 1 is how to get the present value of the receivable or payable. Receivable if you are the creditor and payable if you are the debtor. In here, we have 3 sub-questions to answer. And the sub-question A is, what is the present value of my liability or receivable if I or someone is required to pay a single sum of money in the future? To understand that, let's jump directly to the illustrative problem. Example, you promise to pay someone 3 million after 4 years through a non-interest bearing note. The implicit rate is 12% compounded annually. What is this non-interest bearing note? For starters, note is the shortcut for a written promissory note where the debtor promises to pay an amount in the specific future date. So what is the meaning of non-interest bearing, sir? Well, a regular debt agreement is normally composed of terms for principal payments and interest payments of the debtor, right? So if non-interest bearing, then there is no agreement as to the interest payments. So if you are the debtor, it's as if you are just going to pay only the principal. But the truth is, even if there is no interest agreement, it doesn't mean that there is no interest charge. The interest is already included in the payments. In this case, it's already included in the 3 million. So that interest is what do we call as implicit interest. That is why, as you can see in this problem, there is an implicit rate of 12% mentioned. So again, this 3 million right here is not only composed of principal payments, but it also includes interest. So let's analyze. Is your payable 3 million now? Really? Right now? Of course not. It is 3 million after 4 years. Actually, this amount already includes interest for 4 years. So we need to remove the interest for 4 years first in order to get the amount of your payable or debt now. So the process of removing such interest is technically known as discounting process. So how do we do that? So we can have the timeline analysis. So today is here, and then after 4 years you're gonna pay 3 million, and then you will be debt free. And in the problem we have 12%, so we have to use 1.12 in our working back or computation. So we can work back. So if it is 0 here after paying the 3 million, then that means your debt is 3 million here before the payment. And then let's work back. So we're going to divide 3 million with 1.12 instead of multiplying because we are working back. So 3 million divided by 1.12, you will have 2,678,571. Divided by 1.12, we have 2,391,582. Another divide 1.12, 2,135,341. And the last, divide it by 1.12, and you're gonna get 1,906,554. So your liability is only 1,906,554. It became 3 million because the 3 million includes interest. Of course, there is a shortcut, which is payments times 1 plus interest raised to the power of negative n or negative number of periods. So let's substitute. The payments is 3 million and then 1 plus 0.12 raised to the power of negative 4. So to summarize, we have 3 million times 0.635518,078, which is the summary of this 1.12 raised to the power of negative 4, or the answer. So 3 million times this one, you will have 1,906,554, which is the same with what is the result in our timeline analysis. And by the way, this 1 plus I raised to the power of negative n is what do we call as present value of 1. Sub-question B is, what is the present value of my liability or receivable if someone is to pay multiple times at the end of each period? So it is the same with sub-question letter A. However, you will be required to pay multiple times. For example, you promise to pay someone 750,000 every end of the year for 4 years through a non-interest bearing note. The implicit rate is 12% compounded annually. So in timeline analysis, you are gonna pay here 750,000 and then here also, as well as here, so that your liability will become 0. And according to the problem, the implicit rate is 12% compounded annually, so we are still going to use the 1.12. Now we can work back. If this is 0 after 750,000 was paid, then this is also 750,000 divided by 1.12, then you're gonna get 669,643. But before the 750,000 was paid, it is 1419643, and then divided by 1.12, you will have 1267538 plus 750,000, you will have 2,017,538. You divide that again with 1.12, then you're gonna get 1,801,374 plus 750,000. We have 2,551,374. And lastly, you divide it with the last 1.12, then you're gonna get 2,278,012. So your debt today is 2,278,012. And then we have the formula-based solution, which is payments times 1 plus I raised to the power of negative n. However, we're going to add two other elements, this 1 minus and the over interest. This formula is what do we call also the present value ordinary annuity. Again, payments times present value of the ordinary annuity, which is this formula, is the present value. It's now time to substitute. So the payments is 750,000 times 1 minus 1.12 raised to the power of negative 4 over 0.12. So if we are going to summarize this one, we're gonna get 3.0373493. And then multiply that again with the payments of 750,000, then we are going to get 2,278,012, which is the same with this one. The last sub-question is the same with the previous illustration. However, the 750,000 will be paid at the beginning of each period. So in timeline, it looks like this one. So if you observe, the last payment of 750,000 happened in the end of the third year instead of at the end of the fourth year, because in substance, the end of the third year is also equivalent to the beginning of the fourth year. Of course, we are still to use the 1.12, so we can start working back. So here is 0 plus 750,000, you will have 750,000. Divided by 1.12, you will have 669,643. Plus 750,000, you will have 1419643. Divided by 1.12, you're gonna get 1267538. Plus 750,000, you have 2,017,538. Divided by 1.12, we have 1801374. Plus 750,000, you have 2551374. We can also get this 2551374 by multiplying payments with 1 minus 1 plus I raised to the power of negative n over I. The same with this one. However, we are going to add two elements. One of it is the plus 1 here in the negative n and the final plus 1. So let's substitute. We have 1 minus 1.12 raised to the power of negative 3 instead of negative 4 because of this plus 1 over 0.12 plus 1. And then you multiply that with the payments of 750,000. So if we're going to summarize this one, then you're gonna get the present value factor of 3.4018313 and multiply that again with the 750,000, and then you're gonna get 2551373. There is 1 peso difference. It is because of rounding off factors. And by the way, this formula is what do we call technically as annuity in advance or present value annuity in advance. In some other authors, it's called the annuity due. Before we go to the summary of this slide, I have a bonus knowledge for you. So for example, what if you wanted to get this 2391582 or this 1267538 using the formula approach, not using the timeline analysis? Can you do that? Yes, of course. You just use the formula. These formulas. However, you need to revise the n. So in here, if you wanted to get the 1906, you use negative 4, right? But since you wanted to get this one, then you're going to revise this n. It will become 2. Because from the maturity date, you need only to go back 2 years because you want to get the 2391582. The same with this one. If you wanted to have the 1267538, again, you revise the negative 4 into negative 2. Now, let's have the summary. So, to get the present value of your receivable or liability, or to answer the first question, then if it involves one-time payment only, you use payments times 1 plus I raised to the power of negative n. This formula is what do we call as present value of 1. And if it involves multiple uniform payments at the end of each period, then you use payments times present value of one ordinary annuity, which is 1 plus I raised to the power of negative n. However, there are two additional elements, the 1 minus and the over I. But if it involves multiple uniform payments at the beginning of each period, then use payments times present value annuity due or annuity in advance, which is the same with this one. However, there are another two additional elements, the plus 1 in the negative n and the final plus 1. So that's it for question number 1. Question number 2 is coming right up. We are now on the second question, which is how to get the payment amount. To be specific, let's assume in here that the present value of your debt is given, as well as the interest rate or the implicit interest rate is given, as well as the terms like the maturity date or the payment dates and etc. are also given. What's missing is the specific payment amount. That's what's missing. To understand it further, let's go directly to the illustration. The proceeds you receive from a financial institution today is 2,470,000. The interest rate is 12%. You are to pay an amount every end of 6 months for 2.5 years. How much will you pay semi-annually to settle the debt? So to analyze this, we can use a timeline. However, let me be clear that this timeline cannot find the amount that we are looking for. So we are only going to use this timeline for two purposes. One is to understand the problem further, and number two, later, we're going to use this for checking purposes. So in here, based on the problem, you are going to recognize the present value of liability of 2,470,000, and you should remember that the proceeds that you have received is actually the present value of your liability today. And then according to the problem, you're gonna pay here, 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 and here, and also here, so that you will have a zero liability at the end of 2.5 years. It is also mentioned on the problem that the implicit interest rate is 12%. However, we cannot use the 12% because it said in the problem we are having semi-annual payments. So what are we going to use? We have 6% or 12% divided by 2. So we're gonna use 1.06. So if we're going to simplify the problem, it's as if it's telling you if your liability is 2,470 and it will grow at 6% every 6 months, how much will you pay so that your liability will be fully satisfied at the end of 2.5 years? Again, we can't get the answer using the timeline, so we are going to use the formulas. But first, let's go back to the formulas that we've learned a while ago. So we have three formulas. So if one-time payment, we're going to use payments times 1 plus I raised to the power of negative n. But if the problem is dealing with multiple uniform payments at the end of each period, that would be payments times 1 plus I raised to the power of negative n. However, there is 1 minus here and over interest. But if we're going to deal with multiple uniform payments at the beginning of each period, we're gonna use payments times 1 minus 1 plus I raised to the power of negative n over I. But in this one, we have plus 1 on the negative n and the final plus 1. And since the problem is clearly multiple uniform payments at the end of each period, then we're going to use this number 2. So payments times 1 minus 1 plus I raised to the power of negative n over I equals the present value of the debt. And then we substitute. So in the problem, the payments is not given, but we can get the amounts for the present value factor. So we have 1 minus 1.06 raised to the power of negative 5 divided by 0.06 equals the present value of 2,470, which is given in the problem. So if we're going to summarize this, then we're going to have 4.21236,378, and then we have 2,470. So in order to get the payments, you just have to divide the 2,470 with 4.21236,378, and the payments is 586,369. Let's check if our answer is correct. So we have to put the payments here, and here, and here, and here, and of course here. And let's see if our liability will be 0 after 2.5 years. So let's start. 2,470,000 times 1.06, you have 2,618,200. However, you're gonna pay the first 586,369, then you will only have 203,1831 times 1.06, we have 2,153,741 minus 586,369, we have 1,567,372 times 1.06 minus the third payment, then we have 1,075,045 pesos times 1.06, we have 1,139,548 minus 586,369, then we have 553,179, and lastly we have 553,179 times 1.06 equals 586,369.74 minus 586,369. Supposedly there's an answer here of 0.74. However, the difference of 0.74 is just due to rounding of factors. So we have proven already that 586,369 is the right answer. But let's analyze further. I told you earlier that payments for non-interest bearing notes includes principal and interest payments. So we need to prove that now. So as you can see here, we have the beginning liability of 2,470,000. However, after 6 months, it became 203,1831. So it's safe to conclude that there is a principal payment of how much? 438,169. That is the difference between these two balances. How about the interest, sir? Since we have the total payment of 586,369 and the principal payment is 438,169, the difference of the two, which is 148,200, is the interest payment for a total of 586,369. However, there is another method of getting the interest payment. And how do we do that? Remember, the beginning liability is 2,470. However, after 6 months, it was multiplied by 1.06 and it became 2,618,200. Actually, the difference between that two is the interest payment. So, in short, if you wanted to get the principal payment, you get the difference between the beginning balance of the liability and the ending balance, and the interest payment is just the difference of this one and this one. So let's complete the analysis for all of the periods. So we have the difference of this one is the principal payment of 464,459, and the interest is this one minus this one. We have 121,910, and of course that is still 586,369 all in all. On the third, we have the difference of this one is the principal payment, and the difference of this and this is the interest, for a total again of 586,369. The same with here, you're gonna deduct 1075045 minus 553,179. So that is the principal payment, the difference of 521,866, and the interest is just 113,948 minus 1075045. We have 64,503. Still, it is a total of 586,369 payments. And the last is 553,179 minus 0. You have a principal payment of 553,179, and the interest is the difference between these two. So 33,190.74 for a total of 586,369.74. And let me remind you again that this difference of 0.74 is due to rounding of factors. So that's it for question number 2. Question number 3 is coming right next. Question number 3. The third question is how to get the effective rate if it's not given. To be specific, please assume that the present value of your debt is given, as well as the terms like the payment dates or the maturity term or the maturity dates is given, as well as the specific payment amounts is given. What's missing is the interest rate, just like this problem. The proceeds you receive from a financial institution today is 2.2 million. The interest rate is unknown. You are to pay an amount of 500,000 every end of 6 months for 2.5 years. How much will you pay semi-annually to settle the debt? to understand the given situation, let us explain it using the timeline. So, at the very beginning, you are to record 2.2 million as your liability, which is equivalent to the proceeds that you have received from the financial institution. And according to the problem, you are gonna pay 500,000 each of the 6 months period. Then, if you're going to add this 500,000, all in all, you're gonna pay 2.5 million. So based on our analysis, it is very clear that there is an interest charge because you're gonna pay 2.5 million, however you have only received 2.2 million. The question here is how much is the interest rate? However, we cannot use this timeline in order to get that missing rate. If you can remember, if the rate is missing, we need to undergo trial and error as well as interpolation. To find the unknown rate, we have step 1 trial and error as well as step 2 interpolation. In the last video, we already did the trial and error and interpolation, but in the context of the future value. The steps that we did there, however, are also the steps that we are going to do here in the present value, which starts with the trial and error. But before we do that, we need to fill up 2 requirements, right? So the first one is getting the appropriate formula. Again, we have 3 options, but we are to use 1 minus 1 plus I raised to the power of negative n over I. It is because based on the illustration, it is clear that you are to have multiple uniform payments at the end of each period. Please remember this. If the problem is silent, you assume that the multiple payments are made at the end of the period. The second requirement is the setting of objective. So our objective here is to find the rate that will be applied on the appropriate formula so that the payments, which is 500,000 times the appropriate formula, will result to a present value of 2.2 million. So that's our objective. And since we have already the 2 requirements, the appropriate formula and the objective, we are now ready for the trial and error. Let's say for example, we're gonna try 10%. However, we cannot use the 10%. Why? Because the illustrative problem mentions semi-annual periods. So what rate are we going to use? Of course, 10% divided by 2. So applying, that would be 500,000 times 1 minus 1.05 raised to the power of negative 5 over 0.05. So to simplify, you have 500,000 and we simplify this, you're gonna have 4.32947,667. 500,000 times this one equals 2164738. But since it's lower than our 2.2 million goal and we need to increase this one, so we have to try a lower rate, let's say 8%. Sir, why do we have to try a lower rate? In the past, when we are doing this in the future value context, you said if you wanted to make the future value higher, you try a higher rate. Well guys, that is only true for the future value. Here in the present value, always remember that the interest rate and the present value has an inverse relationship. So in summary, when we talk about future value, the rule is the higher the interest rate, the higher the future value of your investment. But when we talk about present value, the higher the interest rate, the lower the present value of your payables or receivables. Sir, we need the logic behind the inverse relationship of present value and the interest rate. Okay guys, so let's compare and contrast. For example, situation 1, you receive from your loan application 2.2 million, but you are to pay 2.5 million just like this problem. However, we have situation number 2 in which you only receive 2 million but you are still to pay 2.5. Of course, we can conclude that in these 2 situations, there are interest charges because you're gonna pay more than what you have received. However, which interest charge is greater? Of course, the interest charge in situation 2 is greater because you receive lesser proceeds. So let me emphasize it again. The higher the interest rate, the lower the resulting present value is. So I hope it's clear now. Let's go back to the problem. And again, we need a bigger present value than 2,164,738 because our goal is 2.2 million. So let's try 8% as I've mentioned a while ago. But we are not going to use the 8%. We're gonna use the 8% divided by 2 semi-annual periods or 4%. So let's substitute. we have 500,000 times 1 minus 1.04 raised to the power negative 5 over 0.04. To simplify that, we have 500,000 times 4.451822331, and then we're gonna get 2,225,911, and that is our trial and error. But let me remind you again that you can have lots and lots of trials, but the trial and error ends when you have tried two rates which will result near to the desired value. So our desired value is 2.2 million. These two rates resulted nearer to the desired value. And one of the tried rates resulted to a slightly higher value than the desired, which is this one. And the other one resulted to a value lower than the desired present value, which is this one. So that's it for our trial and error. We're now prepared for the interpolation. In this particular step, the first thing that we should do is to arrange the tried rates as well as the resulting present values. So we have 10%, and the 10% resulted to 2,164,738. We also tried 8%, and the resulting present value is 2,225,911. After that, we're going to put in the middle the 2.2 million, which is the desired present value, and the x, which represents the unknown effective rate. The next thing that we should do after the arrangement is to have an equation which highlights the difference between the 10% and the 8%, the first and the second tried rate, which is 10%, the difference is 2% in order to get the second tried rate of 8%. So why do we do this? Because if we're going to get the effective rate, we're going to use this, particularly the 10 minus 2. So we have effective rate is equivalent to 10 minus 2. However, the 2 will be multiplied with a fraction first. And that fraction is, the numerator is the first and the second amount, which is 2164738 minus 2.2 million. Supposedly, the answer is negative. However, we are interested with the positive values or the absolute value. So we have positive 35,262. And the denominator is the first minus the third. So we have 61,173. So in order to simplify that, the effective rate is 10% minus 1.15, or the effective rate is 8.85% per annum, or effective rate is 4.42% per semester or per semi-annual period. Let's check if our 4.42% per sem is correct, and let's apply the 1.0442 in our timeline before. So we have 2.2 times 1.0442, you have 2,297,240 minus your first payment, then you're gonna have a liability of 1,797,240. Now you multiply that again with 1.0442, that gives 1,876,678 minus 500,000, we have 1,376,678 times 1.0442 again, then you are gonna have 1,437,527 minus 500,000, that is 937,527 times 1.0442 again, then you're gonna have 978,966 minus your fourth payment, we have 478,966 times 1.0442, you will have 500,136. This is supposed to be 500,000, but because of our rounding off factors, that's why there's a discrepancy of 136. So this is supposed to be 0. But if you wanted to have the exact rate, then you repeat the trial and error and interpolation. But this time, you need to choose two rates which will result closest to 2.2 million. So that's it for question number 3. The last and the fourth question is, what if we're talking about interest-bearing debts or receivables? Let's go directly to the problem to understand this. So you were granted a loan for 2 million. The interest rate is 10%. You are to pay the principal in 5 years, but you will also pay the interest every year. So actually in here, you have to think that you have two types of debts, the principal and the interest. So if the problem is this simple, then we need not compute the present value of your liability because it's directly 2 million. So what will happen? Let's have the timeline. So here, you're gonna recognize 2 million as the present value of your debt. And then you multiply that with 1.10. It's because according to the problem, the interest rate is 10% and you're gonna get 2.2 million. However, you're gonna pay interest every year. So that is 10% times 2 million. So we have 200,000. And then you're back to 2 million. Actually, on the second year to fifth year, the cycle will continue. Times 1.10 and then 2.2 minus 200,000, 2 million again, until you are going to pay at the end of the fifth year the principal of 2 million. Sir, we want proof that the present value is really 2 million. Okay, then we can use a formula-based solution to prove that. As I have told you earlier, you have two types of debts here. You have the principal and you also have the interest. And since the principal is to be paid only once, which is after 5 years, it would be appropriate that we're going to multiply it with 1 plus I raised to the power of negative n. On the other hand, the interest is to be paid multiple times at the end of each period, so you need to use 1 minus 1 plus I raised to the power of negative n over I. Now, let's substitute. So you're gonna pay principal of 2 million after 5 years and you multiply that with 1.10 raised to the power of negative 5. If you're going to summarize this, then you're gonna get 0.6209213. So this one times this one, you're gonna get 1,241,843 rounded to the nearest whole number. And then as to the interest, you're gonna pay 200,000, the 10% from the 2 million. This is the agreed interest rate times the agreed principal. Sometimes this interest rate is also called the nominal interest rate. So you multiply that with 1 minus 1.10 raised to the power of negative 5 divided by 0.10. And if you're going to summarize this, you're gonna have 3.7907868. So 200,000 times this one, you will have 758,157. So you add them up, the sum is 2 million. So that's the proof that the present value is really 2 million. Things will only get complicated with interest-bearing notes or debts when the agreed principal is not the same with the proceeds received by the debtor. Let's say, for example, we have situation number 2. Let's assume the last problem where you are to pay 2 million principal at the end of 5 years and interest of 200,000 every year. Except that you only receive 1,855,809 from the creditor as proceeds. This usually happens when the creditor charges or deducts something like direct origination costs or service charges or transaction costs and the like. Sometimes, these charges are abused by the creditors. The debtors are usually misled to believe that the interest rate charge is small, but in reality, there are a lot of hidden advance deductions. Anyways, let's go back to the problem and analyze this situation. It is very clear that the interest rate charge here in this situation number 2 is not 10% only. It is higher because you are not just required to pay for 10% interest. The creditor also deducted something from your supposed to be proceeds of 2 million. The question is, what is that effective rate? Surely it's not 10% because if it is, then according to these calculations, you should have received 2 million as proceeds. However, you can find that through again trial and error and interpolation, which if you remember, will start with getting of the appropriate formula. The only difference is that the appropriate formula will be for 2 payments already. One is for the principal and the other one is for the interest payments. Luckily, we already have that. These are those formulas. So after getting the appropriate formula, let's find the objective or let's set the objective. And that is, what is the rate that if we are going to substitute that rate with these formulas will result to the present value of 1,855,809. Next is we will have the trial and error. To make this fast, let's use the 10% because luckily we have already computed and it resulted to 2 million. But in order to get a lower value, because we're trying to find the rate that will result to 1,855,809, we are going to use a much higher rate. Say for example 14%. But before we do that, I'll say this again to remind you that the rate and the present value has an inverse relationship. So if you want to decrease the present value, then increase the rate, just like in this case. Now, let's substitute the 14% in the appropriate formulas. So we have 2 million times 1.14 raised to the power of negative 5. If you're going to summarize this, you're gonna get 0.51936,866. So this one times this one, you are going to have 1,038,737. And then you have the interest of 200,000 times 1 minus 1.14 raised to the power of negative 5 divided by 0.14. So we have 3.43308,097 times 200,000. Then the answer is 686,616. The sum of these two is 1,725,353. So that's it for trial and error. Let's go now to interpolation. But first, you arrange the tried rates 10% and 14% here, and then on the opposite side, the resulting present value. So 10% resulted to 2 million and 14% resulted to 1725353. Then put in the middle the desired present value of 1,855,809 and x representing the unknown rate. And then you need to make an equation that highlights the difference between the first tried rate of 10%. The difference is 4%, and then you're gonna get the second tried rate of 14%. Why? Because we're going to use this 10 plus 4 in getting the effective rate. But before we do that, the 4% will be multiplied to a fraction, in which the numerator is the difference between this 2 million minus 1,855,809, which is 144,191. And then the denominator is the difference between this first 2 million minus the 1725353, resulting to 274,647. And then you summarize this. When you summarize that, you're gonna get 2.10. So meaning the effective rate is 10 plus 2.10 or 12.10% per annum. But if you're going to round off, you have 12% per annum. Of course, you wanted to check if ever that is correct. So let's have the timeline. And let's use the 1.12 because our answer is 12% per annum. So according to the problem, you have a present value of 1,855,809. And then, you're gonna pay after the end of 5 years a principal of 2 million, and you're gonna pay interest of 200,000 each and every year. So, let's see if ever this 1,855,809 debt of yours will really become zero at the end of year 5. So, 1,855,809 times 1.12, you have 2,078,506 minus 200,000, you have 1,878,506 times 1.12, you have 2,103,927 minus 200,000, you have 1,903,927 times 1.12, you have 2,132,398 minus 200,000, you have 1,932,398 times 1.12 again, you have 2,164,286 minus 200,000, you have 1,964,286 times 1.12, then you are going to get 2.2 million. Minus the last interest payment, you have 2 million. And minus the principal payment, of course, it will become zero. That means the effective rate is really 12%. Sir, what if the 1,855,809 is missing, however the 12% effective rate is given? So what will happen? Of course, guys, you will not need to have the interpolation and the trial and error because the effective rate is already there. What you need to do is to get the 1,855,809. And how do you do that? By using the 12% and applying it with the appropriate formulas right here. So meaning, instead of 2 million times 1.10, you're gonna have 2 million times 1.12 raised to the power of negative 5. And here, 200,000 times 1 minus 1.12 raised to the power of negative 5 to get that 1,855,809. Sir, one last thing. This 200,000 is 10% out of 2 million, right? So, the effective rate is already 12%. Do we need to revise the 200,000? No. 200,000 stays as it is. Why? Because you cannot change the fact that you are going to pay 200,000 interest every year as per agreement with the creditor. I hope that's clear. So, that's the end of this video lecture. So if you have questions, please comment that below and I'll try to answer as soon as possible. If it helped, then please click like, subscribe, and share this to those who need this. Please also hit the notification bell to be updated on my next videos.